A very good morning to all the participants. Am I audible? Can anyone confirm if I'm audible?
Yes, it's audible.
Oh, thank you. So, I once again welcome all the participants for this 6 day FDP program. Uh, will move into the next session. Today's session 7. We have with us Mr. Shahul Hamid, who is a quality control officer at Terraforma Ground Engineering, Kingdom of Saudi Arabia. He has completed his PhD from NITTR Chennai and the ME Environmental Engineering from Anna University Chennai. Prior to this, he has worked in as a planning engineer in color ground improvement projects. He has around 10 years of field experience. So we welcome you, Shahul Hamid. Sir, are you there? Can you hear me?
Yes, Professor is audible. Yes. Thank you.
Yes.
Thank you. Yes.
I'll make you the co-host so that you can share the videos. Share your presentation.
Sure, Professor.
Yes. Can you try sharing it now?
Yeah, I'm trying. My screen is visible now.
Yes, it's visible.
Yes, very good morning to all, and I'm very happy to share. Is audible? Yes. I'm very happy to share my work experience for the 6 days faculty development training program in the topic of recent advancement in geotechnical engineering and
Sir,
industrial.
are you speaking something? We are not able to hear you.
Okay, well, let me. Now it is audible. Is Professor now is audible? Can anyone tell it's audible?
Yes, it's audible.
Is audible now. Okay, fine. This is very good morning to everyone here. Actually, I'm very happy to present my work experience for the 6 days faculty development training program in the recent advancement in geotechnical engineering as a industrial perspective. Okay. So today I'm going to discuss about
Shahul sir,
yes, Professor. Yes, yes, yes. Is audible or not? What's the issue, madam?
you are not audible. Now you are audible actually.
Okay, fine. Yes, today I'm going to discuss about the enhancing soil performance strategy for planning and execution ground improvement techniques. So this is a thing I need to sharing with you for this presentation. Okay. So actually, I'm working as a quality control officer in Terraforma Ground Engineering at Maful Al Harabi partner and in Saudi Arabia. So here I'm going to share my work experience, which is related to in the aspect of planning and execution of the ground improvement techniques. I hope in this previous speaker they are discussing about designing of geotechnical work, design aspect they are discussed. So now my discussion is like planning and execution aspect of the ground implement techniques. Okay, so let me start my presentation. So before that, going for the planning aspect and execution aspect, I will tell the basic what we are doing. Okay, then I can go for exactly how to plan and execute the geotechnical work for the ground improvement side. Okay. First, we are what we are doing. We are doing a ground improvements. So we are doing ground improvement for the soil. So we should know about what is ground improvement. Then what are the technique we are using that I can share now. So accordingly, it will be easy for you to understand what exactly we are doing. Okay. So ground improvement, as you know that ground improvement is need for three things. One main thing is bearing capacity. So bearing capacity of the soil. We need to increase the bearing capacity of the soil, and we need to reduce the settlement of the soil, and we need to increase the stability. The three things we are focusing on it for the ground. Okay, so we are going to increase the bearing capacity. As you know that, so if we are going to construct any buildings or anything, we need to increase your bearing capacity. So from the ground improvement technique, we are using, we are trying to increase the bearing capacity of the soil and reduce the settlement of the soil and increase the stability of the ground. So that is the main concept of the ground improvement. So we have many techniques. I will share one by one. What are the technique we are following? Okay. So failure, you can see this picture like failure due to poor soil condition. Many buildings are failed due to the not considering about the soil criteria. So before constructing any structure, we should check the soil condition. So based on that, we need to construct it. So what is the bearing capacity? What is the settlement things? So we need to focus on that. Accordingly, based on that only we need to construct the building. So these are the problems of soil like liquefaction is one of the problem. So liquefaction is one of the problem, and difference in settlement is one of the problem. Then excessive settlement also a problem. So these things we need to construct. We need to concentrate before constructing a building or any other structures. So let me share what we are doing it. Yes. So before doing any compaction work, so we need to test the soil. So like, for example, if you're going for the hospital, or if you're affected by some flu, what do you do? The doctor will check your blood sample. He'll collect your blood sample and he'll find out which kind of flu you are affected. So based on that, they will give the treatment for you, right? The same way. The same way. So we'll go for this ground. We'll do some pre-testing. We do some pre-testing. So based on the pre-testing, so we'll do analysis. So which kind of treatment we can provide for the soil based on the soil condition. So we will provide the treatment. So we'll adapt the treatment. So after the treatment, we do again test. That test is called post test. Okay, so that test is called post test. So based on the pre and post, we will ensure that soil was strengthened. Okay, so that testing is called CPT. CPT. CPT is in the sense cone penetration test. Okay, cone penetration test. So this is a machine I'm showing that this is your machine is like scholar type is available and tire type also available. So basically scholar type is easy for to move in the desert areas. So mainly we are in the Middle East, so majority of the area is like desert area and is near to the ocean as well. So the soil was very silty and also very light. So skull type is best to move from one place to another place to test the ground. So this is you can see it in the next slide. It's like the cone. I'm showing the cone as it's a sensor actually. So cone contains the sensor. So this cone is used to determine the surface condition of the soil. Okay. So you see the machine in here. We have the machine. I'll show. Wait a minute. I'll take the pointer. Yes, you can see the machine. In machine, we have the opening at the one end. Opening at the one end. From the opening, the rod will go slowly. Okay, rod will go slowly. So we have some hydraulic pressure inside the machine. So the hydraulic pressure is pull down the machine inside. The rod will be go down into the ground, and it will collect the data of the soil. So what are the data it will collect? It will collect like cone resistance. It will collect the data of the cone resistance, sleeve friction resistance, pore water pressure, and the friction ratio. So this data we will collect from the soil. So based on the data, so we have the design team is there in our company. The design team are making the design, which based on this soil condition, either it is weak or strong. So based on that, we will provide the which technique or which treatment is good for the soil. Okay. So the hydraulic push will be there. It's at the rate of 20 millimeter per second. We will push. Okay. This is a rod. You can see this is a rod. Is going enter into the ground and is collect this information about the soil. Okay, this is called cone penetration test. This is a mission. Already I have shown. And this is a graph. So while entering into the mission, so the graph will be generated. Okay, while entering to the cone was entering into the soil, the graph will be generated. So graph like I think the next slide is I'm showing the next slide. So I think it's available or not. Okay. Yeah, it's came. See, you can see the rod is going penetrating here. The rod is penetrating here. So you can see the graph here. So the graph is like we have different color of graphs. So different color in a sense, the yellow color is nothing but gravel sand. Okay. And the blue color is like silty sand and silty and the clay content, organic soil content. So we have different color coatings are there in the graphs. So it will start from the 0th meter. It will start from the 0th meter and it start penetrating into the ground up to 1 meter, 2 meter, up to 6 meter, as per the design criteria. So the client will provide the design criteria up to which depth we need to go. Okay. So they will mention in the design criteria like 6 meter we need to go or 10 meter we need to go or up to the where the denser soil will get. Up to where the denser soil will get. So we need to penetrate the cone. We need to penetrate the cone up to the denser soil. So that is a condition. So we can, from the graph, you can get which kind of soil is presented. Okay. From this soil graph, you can found that either the clay soil is presented or silty soil is presented or organic soil is presented. So based on that, we have to come for the conclusion. So which kind of technique we can provide. Okay. So it's all the next slide is like what the sector we have phase one and phase two. For some area we have done some testes is a cumulative graph. So cumulative graph is showing that this area contain silty or sandy soil, which is more we can able to find out from the graph. Okay. And based on the PPT data, so based on the PPT data, we checked what kind of soil and what kind of resistance and what is the strength of the soil we are finding from this PPT results. So suppose the soil is very weak, so we need to adapt some treatment. So treatment like we technique we call technique or treatment. So a technique like we have DC technique. So DC means dynamic compaction. So dynamic compaction means we have the crane. So under the crane we have the dead load, heavy dead load is there. The pounder will falling from some height and it will compact the ground. So that is called dynamic compaction. And we have RIC. RIC means rapid impact compaction. So we have hammer-like structure. Hammer-like structure. So the hammer is keep on damping into the ground and make it compact. That is called RIC. And RDC. RDC is nothing but rapid dynamic compaction. So rapid dynamic compaction is like nothing but the same process. Both RIC and RDC are same, but one thing is the hammer weight is different. Hammer load is different. So the same process of this. The next one is VC. So VC is nothing but vibro compaction. So vibro compaction means vibrator will be there. So there is no other dead load. Is a vibrator. The vibrating needle is penetrating into the ground and make it soil harder. Make it soil into harder, and we put a good soil into it, or that technique is called vibro compaction. DR compaction is dynamic replacement. Actually, DC and DR both techniques are similar, but only thing is we'll remove replacement will do. Replacement we'll remove the poor soil and we'll put the good soil and we will compact. See, we have the ground, so with the bad soil we remove the bad soil and we'll fill up the good soil and make it compact. Okay, so that technique is called dynamic replacement. And vibro replacement also same. We'll remove the bad soil and put into the good soil or put some stone. Either we can put the good soil or we are putting the stone. That technique is called vibro replacement. And we are adding, we apply both techniques, dynamic as well as the VR we are using. So that technique is called VR. So based on the soil condition, based on the CPK result, we will adapt this which technique will suit very particular area. Next one is like we have two categories. One is like fine grained soil, another one is coarse grained soil. So fine grained, we are telling that silt and clay is called fine grained soil, and coarse grained we are categories like sand and gravel. It's called coarse grained. Okay, so for fine grained, okay, for the coarse grain, I'm telling for coarse grain, sand, silty sand, gravel, mano gravel, and the dune sands. This comes under categories as a coarse grains. So for this, we are adapting technique like dynamic compaction or RDC compaction or vibro compaction. So this are the technique we are adapting for the coarse grain soil. And if it is a fine grain soil, if it is a fine grain soil, we are adapting technique like dynamic replacement and vibro replacement, rigid inclusion, prefabricated vertical drains. This kind of technique we are adapting for the fine grain soil, because the fine grain soil is like a silt, full of silt. So we need some advanced techniques. That advanced technique is called dynamic replacement or vibro replacement, other techniques. So based on the soil criteria, so we are adapting these techniques. So first, initially we'll test the soil based on which soil is presented. So accordingly, we'll choose our technique. Okay. And next one is like how we are selecting the technique. How we are selecting the techniques. We have simple method like you can see the legend L1, L2, L3. L1 is nothing but sand IC. IC mean soil behavior index. So we'll calculate the soil behavior index. It is less than 2.505, or if it is greater than 2.05, or if L3 is nothing but hard data. Okay, so from that we are classifying the technique. For example, you can see hard data is we can get from 1 to 4 meter. If you reach the hard data from 1 to 4 meter, see L3 is coming up to 4 meter. So we have sand. L1 is only sand. If it is like that, we will adapt only rapid dynamic compaction, the treatment up to 4 meter. Okay. Suppose your depth is more than 8 meter, 4 to 8 meter. Your heart state you're finding the heart data up to 8 meters. We are adapting the dynamic replacement. And for the dynamic compaction, your depth of heart data is more than 12 meter to 14 meter. So we are adapting dynamic compaction, but we need to ensure that there is no silt content is present, which means L2. If the silt content is present, we should go for the dynamic replacement. Okay, so we need to ensure that there is no silt content, but the depth the heart data is more. We can go for dynamic replacement. But depth is less, but the silt content is presented. We should go with only the dynamic replacement. And vibro replacement also there. The vibro replacement, we have two types. One is dry method and wet method. So dry and wet methods are there. So suppose the depth is more than 12 to 50 meters or more than 13 meters. You can consider up to 13 meters. You will get the heart data. You will select the methods called vibro compaction. So suppose without any silt content, we'll go for normal vibro catch. That is dry method. Suppose if silt content is presented, we'll go with some wet type method. Okay, wet type method, we'll add some stones. In VC, we can add sand. Suppose the silt content is more, we are using some stone column techniques and we are adapting for it. So based on the depth of the your heart data and based on the silt content, the choosing of technique is changing. Okay, so everything is based on the CPT data. Okay. And for the execution, before starting any work, we will choose some trial area. Actually, in all companies, they never, just like that, they never accept to start. So before that, we need to do some trial work. Okay, so once the trial is accepted by the client, so they will allow us to do it. So based on that, we have the drawing. So from the drawing, we choose some area. So from that area, we'll do some trial activity. So from the trial activity, we can able to find out how many blows is required because the dead weight is going to come down, right? So we need to find out how many times I need to tamp. Okay, from which height I can put the dead load. So that calculation is based on the trial area. So from the trial, because every soil is different, one place to another place. So if you're going to start any work in the new site, we'll do some trial work. So based on that, we'll calculate how many blows we need to give and how many energy we need to put and from how much height we need to provide the dead load. Okay. For example, I can see the graph. You can see the graph like one side is penetration. So penetration you can calculate from the machine. So machine have the sensor, machine have the data will provided. So we have the machine from the client, we have the data. So we can able to find out the penetration from the penetration depth from the machine. So we'll adapt like we'll give one blow, two blow, three blow. So up to when we don't have the penetration is zero. When the penetration is zero, so we'll find out, okay, this many blows is required for this ground. Okay, we'll do some three trials. We never take only one trial. We'll do some three types of trial with different grids. So we can able to find out exactly how much blow is required for this ground. We can adapt. Okay, and how much height also we can able to tell them. Okay, this is one of the technique. And this is like the next slide is like grid. Just a minute. Yeah, the grid actually for the DR area, the grid size is different. For DC area, the grid size is different. The grid is nothing but one. What is the distance between one blow to another blow? That is one print to another print. Okay, what is the distance between one print to another print? For generally the DC for the phase two, we'll consider like a 8.5 meter into 8.5 or phase one a 6 into 6 meter. For the DC, for the phase to 7 cross 7 and 5 cross 5. So it is based on the trial test. We can select from the trial test. Okay. These things the technical team we have and the design team we have that the design team will suggest us the distance between one print to another print accordingly. And we can go for the dynamic compaction. So first, what is dynamic compaction? Which nothing but we have the dead load. So if the ground is loose, the dead load is falling down and make it compact, make it improve the soil, and we can fill the soil. That's it. We can fill the soil. You can see the animation running on. So the ground is initially it was weak. So we will start damping on it to reduce the gap or any air gap or any particular gap is there. We can remove that gap with the help of the dead load. Okay, so after compaction, we'll do refilling. Okay, this is called dynamic compaction. So you can see circle-like structure. So circle like this is called print. We call print. So we'll select the ground and we'll choose the print and how many prints is required for this ground. We have the calculation. So accordingly, we made the print and we can start the blowing on it and we'll make it ground strengthen. Generally, dynamic compaction is it's a technique to use for the loose soil. It's used for the loose soil and effectively is an effective and economically densification to the improve the ground actually. It's an economical method and then generally it's used for the loose soil. Generally used for the loose soil. Okay. You can see some of the picture like we have done some compaction, so it will create some holes. It will create some holes. So from these holes we are filling the sand after that. Okay, the soil initially it was loose. After the compaction is make a hole. Just a minute. You want to take something? Yeah. Okay, so these are some of the image which I have done or ground implement techniques. So it will create a hole. So from this hole, which means that much gap is there. Okay, that much gap is there. The soil was densified. Okay, then it again it's filled by the soil. I'll make it level. And this another picture which is taken from the sides. Okay, while doing the compaction process. Yes, the depth of the height and the diameter of the the weight, everything is calculated based on the trial test. The next technique is called dynamic replacement. So dynamic replacement is nothing but the ground will be compact. Okay, then the hole will be formed. Then the hole again is filled by the sand. Again is filled by the good condition of the sand. Okay, you can see the picture. So the weak ground is compacted. It make a hole. I will show it again. I'll show it again. Wait a minute. Yeah. Now we can able to see that the ground is weak. The dead load is coming down. The dead load is coming down. So it will make a hole. Then we will fill the good sand. Okay, we'll give the good sand. Again, it was compacted and make it level. So this was done for the entire ground. Entire ground. This dynamic replacement is suited for where the soil contains silt particle. Where the soil contains silt particle, that kind of land we are adapting the dynamic replacement. Okay, so to strengthen the soil. Okay, so dynamic replacement is an extensive technique for DR compaction. So DC is normal. DC, we are simply compacting, we are not filling anything. But in DR, we are replacing the sand and we are filling the good sand and compacting is an advanced technique. So that's the only difference between DC and DR. Okay. Okay, now it's audible.
Yes,
Again,
now
next
you're
is
audible.
this picture is like, yes. Now this picture is like a pounder. So this is a pounder. You can see the weight. Maybe the weight is changing from 10 ton to 33 tons. Okay, the weight we have different type of pounder. So so based on the ground condition, we'll adapt the pounder weight. Okay, so so then basically is the pounder range from 10 ton to 33 tons. Okay, so this is the weight of the pounder. That is called ironing. Then we'll do post test. Okay, this is a technique. So pre-test and post-test is very important. So in between, the technique is based on the pre-test. Okay. So we'll check after checking the post EPT, either the result has failed or passed, we can able to find out. If it is failed again, we need to compact again, and we need to redo the test again. Yeah. Next, we'll go on the planning aspect of the ground improvement work. So, initially, suppose if you are working as a planning engineer, or if you are working as a planning engineer in geotechnical project, how to plan our work, that I'm going to share. Because I was working in Keller in the last year in Abu Dhabi, UAE. So from that, we have worked some project. I'm going to discuss that project, how I made the baseline program, and what are the planning aspect we need to do that. Okay, that I'm going to share in this presentation is the second part. You can tell it's the second part. Okay, so baseline program for the project planning. So before starting any work in anywhere, so we need to submit the baseline program. So baseline program is the Bible of the work. Okay, from the baseline program only we can follow up how many days it's required. So from the baseline program, we can able to calculate how many days of the project from day one to last day. What are the work we are scheduling it? Who are all coming for the work? Who are all manpower? How much manpower are you going to use? What are the equipment you are going to use? So everything we are from the baseline program, the client may easily understand and they will accept it. So the first file is baseline program. Before starting your work, the baseline program file must be approved from your client or consultant. Okay. So preparing the baseline program. So what are the document is required? The very first document is required nothing but the project contract document. Project contract document. That is important. So while because you should know about what is the contract detail between you and your client. Okay, you and your client, what is the contract dealing? What work? What is the scope of your work? Then what are the things we are going to do? So everything is based on the contract document. So first we need to read the contract document. Okay, first. So in contract document, in legally the scope and the deliverables and BOQ and technical specification is mentioned in the contract document. So we should read the first the base I mean contract document first, and BOQ is must. We should read the BOQ. Okay, we should read the BOQ. So BOQ is nothing but we know that bill of quantity. So like for example, if we are going to do any excavation, I show in the next slide how much quantity, what's the quantity of the per meter, and what is the amount of this particular work. So is explained in the BOQ, bill of quantity. So they will explain in the BOQ. So from the BOQ, you can able to understand the quantity as well as the cost. Accordingly, you can plan your work. So reading your BOQ is must for planning work. Okay, we should read the contract document first, and we should read your bill of quantity, and we should read the drawings and design document, because we have different type of drawings available like in field we have different type of drawing like architectural drawing is there, structural drawing is there, MEP drawing is there, some shop drawing, and some approved design drawings are there. So generally, based on our work, which drawing is needed, we need to read the drawing first. Okay, from the drawing, you can able to identify how much area we are going to work, and we can able to find out any abstraction or there on how much distance between one area to another area. So that thing you can able to come for the conclusion based on the drawing. So reading a drawing is important for the planning of your geotechnical work. Not only geotechnical, all work. You can consider all work is a basic thing. So after first you need to read the technical, I mean contractual document. The next one is BOQ we need to read, and third thing is so reading your drawings and design documents. Okay. So next one, project scope document. What is your project scope exactly? What scope you have? What is the contract between you and your client? So the was project scope we need to review on it, and also we need to do the WBS structure, work breakdown structure. So based on your we need to plan our activity like how to create a WBS. That is important. So work breakdown structure, how to create, what's the first work, what is the second work, and any other sub branches. We need to split the work, because if you split the work, you can able to organize your planning work. So that is a kind of skill. Okay, to making your work breakdown structures a kind of skill, okay, that we need to develop it. And we need to know about the milestone and deliverables. So milestone is nothing but when the client is asking to complete one area to another area. So what is the important dates to hand over? So that things comes under the milestone. And we need to find out the critical activity and critical path. If we have any work, we should find out the critical activity. So because we cannot change anything in the critical activity. So we know that critical activity is nothing but your float value is zero. Your float value is zero. Float is zero is nothing but what? So we don't have any days to delay. If you delay on your critical activity, your project duration will be extended. Your project duration will be extended. So if the activity is falls on the critical area or critical part, we should complete on that activity. We should focus on this activity first. Then remaining we have some float value. So float value 1 or 2 days or 3 days we have some float value. We need to adjust the work and do it. But we should focus on your critical activities first, because we cannot make any single day for your critical activity. We need to complete on time. And related to resource document. Next, we have crossed that one resource. We have collected this data. Next one is resource document. So resource document is nothing but how many labors they are working, how many operators they are working. Okay, then what are the equipment I'm going to use? What are the material procurement plan? Anything is there? or how what are the material I'm going to procure for this project. So this data we need. Okay, this data we need to collect from your team. So this data maybe your project manager they may provide, or your teammates or your operation managers they have some idea. We need to sit up with them and we need to and collect the data. Okay, research document is needed. Okay. The next one is like project constraints, risk, project constraint and risk documents. So what are the project constraint is there, or we have any risk is there for your project? We should find out the risk first. Risk means any problem, any abstraction or any struggle what you are going to face in this project. We need to find out the risk first. Okay, so for example, we need to find out the permit and approval, where I can get the permit and when I can get the approval, and we need to maintain the risk register. If we, while starting the work, we'll find some risk. For example, some area is not available. It may be contained forest or it may be contain some water bodies. So we need to identify and tell to the client this area is we cannot work. Kindly hand over this area. We need to work for our plan for our work. So based on the site visit, so we need to maintain the risk register. The register should be inform all every weekly meeting. Okay, that should be forward to your client. And logistic accesses and logistic, because we need to work on it what is the transportation, which kind of transport is coming, what are the vehicle is coming. So we need to plan our logistic items. For example, when I was working in Abu Dhabi, we are working inside the sea. That is an artificial island making project. So in that part, so we need to transfer our equipment from the land area and we need to cross the sea. We are using the ship. Okay, so we are with the help of the ship, we are transporting our equipment, and again the logistic is coming. We need to shift into our site area. Again, we are using some land, land trailers we are using to shift. So based on our work, we need to plan our logistic area because logistic is purely depends on the cost. Okay, so before planning, we need to consider which kind of mode you are transporting your vehicle. And also, suppose if you are transporting your laborers or if you are transporting your engineers to work in your site, we are using three modes. One is from their accommodation to site. The next thing is we need to cross the sea, so we need to use some boat. So the charge for the boat we need to calculate. Again, they want to go inside the site, so we need to use again the transportation. We need to provide again transportation to them to reach the site. So three types of mode of transport we need to provide. So we need to make a logistic plan for your activities. That is very important. And some key assumption we need to made it about the weather condition or shifting, like the things we need to consider. So this risk and project constraint is very important while doing planning of your geotechnical works. And project management and planning documents, like this is like project management plan, overall project management plan into the what is the planning, execution, and how we are going to monitoring, and how we are going to monitor the cost based plan. Okay, and what is the quality plan, what's your health and safety plan, and what is the community plan, communication plan with your stakeholders. So this document also we need to maintain while doing the planning work. Okay, and other documents like subcontract and supplier information, and productivity rates, and method of statements, and EII, environmental impact assessment document, and local authority guidelines and risk assessment register. We need to maintain this document. And here, one important thing is method of statement. Before starting any work, we need to submit baseline program as well as the method of statement. So what is method of statement? Method of statement is nothing but the summary of your work. What kind of work you are going to do, what kind of equipment you are going to use, then what kind of result you can provide to your clients. So entire detailed information about your work, that document is called method of statement. That should submit before starting your project. The client should approve your method of statement. Okay, so without approval of the method of statement, we cannot start your project. Okay, So we have in Middle East we have some different code, code D, code B, and code C, and code D. So code D is what rejected. Code C you can revise and resubmit, and code B you can start work, but you need to revise the document. Code A is nothing but yes, is fully accepted. No need to resubmit any document. Is accepted. So we have different code for each document approval. So I'm telling about the approval of the documentation. So before starting any work, we need to request, I'm going to start this work, I need your approval. So without approval, you cannot start any work. If you start any work without approval, they never consider your work. They never claim your money. Okay, your money, everything is based on your documentation. So we should get approval before starting your project. We need to inform them, I'm going to start this work, give approval. Okay. This is method of statement. The next thing is like other documentations, like we need to follow as a planning engineer, we need to follow up the daily report, weekly report, and final report. Final report. So this three report is very important if you are working on the planning side. So every day we need to submit the report. What work we have done, how much work is completed, how much work is balanced. Okay, that we need to, we call it as daily report. Okay, and weekly report nothing but every week with a summary of the work. Every week we need to give the work progress report, and we need to present to the client. That is called weekly report. The final report is nothing but after completion of your project, we need to give the summary of your entire project and we need to submit to the client. That is called final report. I can show you that baseline program how I made it. I can show my
Sir, your voice is not clear, sir. I'm not able to hear your voice, sir.
I'm opening my file is stuck in. Wait one minute. I can open my.
Okay, sir. Thank you, sir.
Yes. Now it is audible. My voice is audible.
Yes, sir. Please go ahead, sir. Please. Thank you.
Actually, this is one of the projects we have done ground improvement work for the Ramhan Island. This is Ramhan Island is one of the island is in recent development island in Abu Dhabi. Okay, so this is an island. So so we are working ground improvement work for this particular island. So I will show you how I made the baseline program for this particular work. Okay. So initially, the baseline program will start with the front page, like what is your title of the project, what's the name of your project, and who's your employer, and who's your PMC, that is project management consultant, and who's the site supervision consultant, and who's your contractor, and when you are going to start your project, what is your duration of the project, and when you are going to complete the project expectation date, and what is the cost of the project, so that we need to inform in the first part. Okay. The first page should be like that. Okay. So next, like what is the information we need to provide? We need to provide the drawings, the key drawings. The many islands will be there. So the consultant, they will provide only the little area first. They will tell phase one and phase two. This is like phase one part. We should highlight the drawing. So this area I'm going to work initially. First, I need to work on this area. So we need to highlight that area, and we need to tell them each area each area contain this much available area of the each island. They have little small islands are there. So the collection of island is called Ramhan Island. There are many little islands are there. So each island holds the area. So because based on the area only, we can able to find out the time when I can able to finish the work. So we need to mention the area with the help of your survey team. With your help of your survey team, they will go and mark your point, and they will find out the area of particular. Then they will give it to you. The next one is workflow. How we are going to work. So then what are the things we need to start the work that we need to type entirely, like pre test and compaction and post test. We need to tell them. Okay, we need to inform them. Yes, I have mentioned here. So first we need to mobilize our equipments, and we need to start our pre-CPT work and ground improvement design, and we need to do some trial works and approvals, then ground improvement and post work, post test and handovering. So we need to tell them this is the work I'm going to follow. That we need to tell them clearly. And we need to mention the crew movement. So crew movement is nothing but first where I'm going to start and where I'm going to end. So that is called crew movement. We need to make a diagram, and we need to tell them I'm going to start this area first, and next time following with this, after completing I'm going for this island, that island. We need to represent with the help of the drawing to understand the client easily. Because if you made like this, the client will easily understand to about your work plan. Okay. Next, like other documents, like how we are making the bar chart, and what are the documents risk we are going to maintain. That is purely is depends on the planning part. Okay, you will understand when you're working for the planning side. You will understand. The next important thing is work breakdown structure. So we need to make our work breakdown structure. So we have lot of work. So the work will be distributed. What is the first and second and third? It's followed by which work? It's continued by which work? So that is called work breakdown structure. So we need to make the work breakdown structure first. The next one is like we need to give the IDs for the each activities. For example, if your procurement activity, we should give some ID, and shop drawing, we should give some ID. For the material and method of statement, we should follow some ID. So we should go with like this. We should make some activity IDs first. Okay. So we need to explain them in the particular document. And main thing is calendar duration. Okay, we have different set of calendars for different workers. So we have 5 days calendar, 6 days calendar, and 7 days calendar. For example, for 7 days calendar, we can use for the procurement team. For the 6 days calendar, only for the engineers and the construction activity. 5 days calendar only for the client and authority of the permit. So because that guys are working only the 5 days, they're not working on 2 days. And what are the holidays for the particular project is falling on? So we have some national holidays and other newer holidays are there. So we should mention the what are the holidays I'm going to is falling on your project duration, because based on that we need to calculate the duration. That is also important. Okay. The next important thing is like okay, for one CPT, what is the manpower you require? Okay, CPT machine is required, CPT operator is required, helper required, survey helper is required. So based on that, for each and individual equipment, we need to tell them uh, how many, I mean, how many manpower equipment is required. So we need to tell them. Okay, per day, how much it will complete. For example, one CPT machine able to complete 26 point per day. One DC machine can able to complete 1800 square meter per day. One DR machine can able to find out, I mean, finish 1400 meter square per meter. So based on that, we can how we can calculate that we have the area. So we know one machine per day it is calculating this area. So we can able to come for a conclusion when we can complete the project. Okay, so for that, this information is required for the ground improvement work and also geotechnical work. So per machine efficiency, how much area it will complete, that we should know. Okay, that only based on that only we can able to conclude that duration of the project. Okay, and some notes. Your company actually have been working killer, so much for criteria conditions we need to tell them. Okay. The next one is like critical part. So we need to find out the critical part. We need to make a program in StatPro, and sorry, not StatPro, program in P6, Primavera. So we should find out the what are the critical activity, and we need to submit to the client. Okay, and this is a detailed planning program is created by the Primavera. And the next one is manpower histogram. So manpower histogram is like we need to create an S curve. S curve is important for the planning. So we should show them. So from first week, how much equipment I'm going to use. Next week, how much equipment. So it will go on up to end of the project. How many machine is coming for this week? How many machine I'm going to use. That work plan should be you should plan your work to submit your client, because we should have the plan when we are going to start the work, how many equipment is required for this week, and we need to tell them to your team. So I need this equipment for this day. I need to start this work. That aspect we need to follow up. It's easy for to follow up them. And also this is for equipment histogram. Previously, it was manpower histogram. This is equipment histogram. This is purely only for the machine. RDC crane, or CPT machine, or JCP, whatever the equipment is coming. So we are need to make a weekly the progress. I mean, planned equipment histogram we need to make before starting the project. Okay, so we should follow this document. When okay, it's like planning. How, because you guys are from faculties, you are planning your curriculum, right? So before starting your curriculum, you are planning your work. You are submitting your notes of lesson to your principal or someone who is guiding them. So they will approve it. Okay, it is okay. You can follow it. And when you are going to start your I mean, the term test or some semester examination. So accordingly, you can make preparation and you can complete your task right. The same way when you are going to, arrange some guest lecture, what are the program you are going to organize, the same planning is coming. But in different ways, some organized way, we are doing it. Even same primary I can use for your academic purpose also. The next thing is like S curve for the workflow. Okay, for first week I need to complete this percentage. Second week I need to complete this percentage. Last week this much percentage. After end of the week I need to complete 100 percentage. So we should make the S curve for your workflow. So S curve for the or your equipment, S curve for your manpower, S curve for your activity. Three kind of S curve, and last one is like cost S curve also. You need to make your cost S curve. Okay, cost escrow also we need to make it. Okay, per week how much cost we need to collect, and I have shared this drawing because I don't want to share my cost flow here. So this is the way. So this is the kind of document before submitting your project we need to submit to our client. This is called baseline program. So baseline program is an entire detail about your work. Okay. So from the baseline document should be approved. Then after that you can start your work. So after that, we need to submit. I'm telling about now execution part. Once your document is approved, we can start our work. We can do your pre-CPT and post-CPT, and we can start our work. So every day we need to submit the daily report. The daily report nothing but so I see for one zone how much area we completed for last day. Okay, which activity is done, either pre-CPT or post-CPT, or which one is done. I can show my daily report here. You can see here. So and now I'm working on offshore gas plant like Fadhili gas plant is in Saudi Arabia. So we are doing working on it for Fadhili gas plant expansion work. So ground improvement work we are doing. So we need to tell them who are all engineers are working and who are all manpower is working. What are the equipment I'm going to use? Last day I'm work. I need to highlight the work. Last day I'm using RIC work, CPT work, and forecasting. In future I'm going to use this work. This is the area for each zone. This area was completed. Remaining this much area, this much percentage is completed. Okay, so we need to tell to the client about the CPT also, how much CPT is done, how much remaining, and standby details also. So your equipment is standby or without any reason, without permit, or your HSC officer stop. We need to indicate the timing also, standby hours. And next thing is we need to give the drawings. So drawing is like a green color means completed earlier, the red color means done last day. So from the drawing, every day we need to provide the drawing to the clients. So they easily track our project. So where we are working and how much area is completed. Okay. And this is also some other area. So green color area is nothing but work is already done. So red color is nothing but we are work on yesterday, I mean last day. So remaining uncolored one is we need to compact. We need to do compaction. This area is remaining. So from the drawing, the client will easily understand your workflow. So this is called daily report. So every day, if you're working in construction project, you need to submit your daily report to your clients. So this is the first part of execution. The next one is weekly report. I will show you how we are submitting our weekly report, how we are presenting our weekly report to the client. I'm showing you. Yes, weekly report is nothing but this is the ground improvement work we have for the Ramhan Island we have done. So I will show you that weekly report. So from the weekly report, we will make some agenda. So what are the content I'm going to explain for the weekly report? That agenda we need to make it. And the first thing is like we need to tell the safety activities. What are the safety activities I done for the last week? What's the safety activity I implemented for the last activity? That is the first slide. And the next slide is nothing but statistics. How many works I was worked, man hours I worked, any safety accidents occur or not, any environmental issues or happen or not, any accidents occur or not. So based on that, I need to report them. This report they are asking first, safety and the statistics. Okay, how much direct employees work, indirect employees are work. That's the detail we need to submit. And next one is like for the last week, how much area we completed, how much area is completed for the last week for each day, and end of that one we can able to calculate the total area. This much total area I was completed in the last week. We can tell them easily. They will reply to us. In the meeting we need to present. You can see that from the Primavera, so we can able to find out starting date, ending date, and the your forecasting date. Actually, this project was 23 days was delayed. Okay, so you can able to calculate with the help of your Primavera software. So from the Primavera, I'll make this graph. Then this is also from the Primavera, like how much percentage we done before last week, from this week, what's the forecasting this one, that one, the calculation also made. And delay activities. The next one is for this week, why the delay was occurred. So what are the delay activities? How much percentage was delayed? So we need to tell them the delay activities to the client for every week. Every week we need to tell them the delay activity. We need to find out the delay activity and need to tell them. And they're from the Primavera data. And we, based on the delay, we need to plan our work and we need to submit the longest part. You are update your program and we need to submit the longest part, and your solution we need to tell them. And the next thing is like risk assessment. Risk list we need to find. So last week, what are the risks you found? Okay, the it is either we have different color code. Red means high, and mean orange means less than mean major, and minor and very minor. We have different color code. So your risk is comes under risk code. Based on that, we can do it. So this risk we need to inform to our client. So the client will give the rectification of the work. And it's like procurement, we are working on stone column works. We will purchase some stone columns. So last week and before week, how much stones we received, what is our other procurement was done. The procurement detail we need to display to our client or consultant. And this is a S curve for the work progress. So how much we planned, how much we achieved for the last week. Each and every week, how much we planning, how much we achieved, that we need to show to the clients. From the graph, they will easily identify either we are going delay or ahead. They will find out. And like this thing is each zone, how much percentage is done, remaining. I'll show the important one. Okay. The next one is like work 2 week work ahead plan. So we need to every week we need to submit 2 week work ahead plan. So what I'm going to do for next 2 weeks, that plan also we need to given to the client for easy understanding. And the next thing is like manpower histogram. Every week we need to submit manpower. How much we planned, how much we achieved for each week. Okay, so how much we planned, how much we achieved for the manpower histogram. And equipment, next topic is equipment histogram. For the equipment, how much you planned, how much actually is presented. Okay, it is many times not equal. It comes in a different way because site condition is always changing. Planning is always differ from the execution. And the next, this slide is very important. This is like a documentation. So how much method of statement you submitted, either is approved or not. Okay, either this falls on code A, code B, or code C, whatever these things. Okay, and how much shop drawing you submitted, how much you are planning and submitted is approved or not, which code A, code B, or is under review or not. So this kind of details we need to show to the client. Accordingly, they will plan. So this is pending, they will sanction you and they will allow you to do it. Okay. The next one is yeah, if in your site having any NCR or SOR, they will claim and they will site observation report or non-confirm report if anything is there. It's related to PQC as well as the sorry safety department. And anything is related to approval or authority on NOC things we need to display to them. This approval we need or this NOC report is pending, we need to show them. And commercial and payment, we should show them the payment for the last week we received or not, and we didn't receive. We need to mention them. I deleted the slide, only the content I placed. And we need to tell them the site activity. So site images, last week, what we are done, the picture they will ask. Okay, the site picture we need to show them. Okay, the site we, this one. So based on, I already, as a planner work, we need to do the daily report, weekly report, and final assessment report. We need to plan this three report, and we need to submit to the clients. Okay, I think so. We are from Terrafama. We are doing ground implement work. In the Middle East, we have a company. We have a branch in UAE as well as Saudi Arabia. So yeah, we are doing on ground implement work. Okay, then thank you for the opportunity. I think so. I completed my task. What madam is assigned to me. I'm happy to share my work experience with you all. I explained you like what we are now doing, what techniques we are following, okay, and what is the planning expect and what is the execution expect about the ground implement technique I was explained to you. So if you have any doubt or any clarification, any discussion you need, you can ask.
Thank you, Dr. Shahul. Thank you.
Thank you, Professor.
Thank you. And thank you for elaborating the entire process and the uh, showing us a lot of documentation, how it is done and all those things. Now the platform is open for discussion. Participants, you can clarify your doubts or you can have some discussion. Any discussion from the participants side?
Um, Sir,
Yes,
Mr.
sir.
Shahul, Mr. Shahul,
Yes, Professor. Yes, Professor.
the thing is like in your projects, what is the maximum depth of improvement which you have attained? Like when you go for stone columns or when you go for any vibro compaction, what is the maximum
Okay.
depth in all of your projects based on your experience? What is the
So for the
maximum
stone
depth?
column, we'll do 10 to 12 meters. 10 to 12 meters. Already I have shown that slide, right?
Yeah, yeah, yeah,
So
yeah.
average of stone column is like 10 to 12 meters we can do compaction. If it is less
Oh,
than 4 meters, we will do RIC work.
yeah. RIC impact compaction, right?
Yeah, yeah, rapid impact compaction. Yes, Professor.
Okay, 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 okay. And see, mostly, can you comment about the groundwater table? It's like you are doing the works close to the shore areas, right? Maybe
Yes,
during
yes,
when
yes.
you are creating this kind of island and other things. Can you
Okay.
comment about the groundwater table? How close it is to the ground, or how far it is from the ground level?
Yeah, actually, the groundwater table, actually, they will make some seed piling. Before starting the work, the client will hand overing the site, they will do some seed piling. So we
Okay,
don't worry about the water, either it will come or not. That we don't
okay,
worry about that. Yeah. Suppose while doing your PCPT work, you can able to find out your water pressure is coming.
hmm.
If you observe, we never touch the ground. We
Okay,
never
okay,
touch the
okay,
ground. So we need to tell the client this area is not ready. We cannot work. Kindly do some other activities to start our ground because our missions are very heavy. If you are
okay,
working on the water table is very less, then it's not possible to compact.
okay,
Yeah. So we'll tell them clearly this area we cannot work and you kindly do some other seat piling work or some other technique you can follow and give it to us.
okay. So
See,
majorly the works are
they will see they will do some stone pitching work. In what I observed from my experience, so they in seashore we are working on it as an artificial island. Already they have some stone pitching work.
okay.
Stone pitching work is there, so the water cannot be entered into your work area.
Fine, sir. And
No,
okay, the diameter of the columns are usually 1 meter or even more than 1 meter. Do you do
which diameter? We have many techniques.
stone columns?
Even for, I think, point 0.5, point 0.5 to 1 meter also we can, it's possible.
Okay.
Not more than 1 meter. Not more than 1 meter, I'm sure. Not more than 1 meter.
Okay.
1 meter
Point
is
five
very,
to. Okay. Point
yeah,
five to one
point
meter,
five.
right?
Yeah. It's not more than 1 meter. It's not possible. We cannot
Okay.
do more than 1 meter, yeah, because the hole is very less.
Mhm.
Yeah, I can
So on
show
an
you
average, in all of your sites, maybe how many stone columns do you do per day?
per day. So per day
Mm.
we have both shift day and night. So
Okay.
per day it's possible 45 stone columns. Average
For
45.
okay, on an
One
average
visit,
40
yeah.
to
I'm
45.
talking about, yeah, average of for the drying method. Even if it is wet method, it's possible to do 50.
Okay, okay. Little more when it comes to
Yeah,
wet
wet
method, right?
because wet we can do 2 columns at a time.
Okay.
But dry we need to do only 1 column. Only one driller is there.
Fine,
So
fine, fine, fine.
yeah,
Okay, Shahul, it was a nice presentation and
yeah.
thank
Thank you,
you.
Professor. Thank you.
Yeah, yeah.
Mm.
Thank you, sir. Any other questions from the participant side?
Sir, I am Dr. Anand Babu from Sedu Institute of Technology, ma'am. Sir,
SI
from
Sedu
Karyapati.
is perfect. Okay.
Really presentation and the live presentation, which is showing your project also very nice manner, sir. So that it is showing from the initial onwards, you are given a clear details. That is,
Okay.
first you started with that. What are the parameters we have to check the initial stage, and then further process also you have given, and then monitoring and discussion with the client also you are given a clear manner. And then previously, I have experience in Saudi Arabia in uh, power power plant steam power plant project there.
Where you worked? Which company you worked?
Uh, it's Honda Heavy Industries, HHI.
Okay. Is
It's
a geotechnical company or what?
nearby the shores.
Okay.
Okay, in that time, na, I have a lot of hurdles. As a
Mm-hmm.
as a planning engineer, I face a lot of
Okay.
hurdles. While this presentation is useful for in that time also, right now I have a lot of updations from your presentation. Thank you for your
Okay.
presentation.
Thank you, Dr. Anand. Thank you so much. Happy to see you. I know you're professor from R. Mohan sir, right? You are head of the department. I know. Okay.
Sir, I am Dr. Anand Babu from Sedu, sir.
Yeah. I'm talking about your HOD. Your head of the department is R. Mohan, Dr. R. Mohan, right? Now,
Yes, right, sir.
yeah. No, I'm very close to him. I'm very close to him. You can talk. He know about me.
Okay. You are a alumni of Sedu, sir?
No. I'm not alone. No.
Okay,
I
right.
know. Yeah.
Okay.
Yeah. Thank you.
Kindly share your mail ID, sir,
Yes, I can share my email ID. Okay, we can share.
so that in further days, let me communicate and get the information
Sure.
and share.
Yeah. Okay, we can share. No problem.
Thank you, sir. I think there is no other discussion from the participant
Give me a
side.
minute, ma'am. He's not yet shared the mail ID, so
No,
please.
I'll share it in the group, sir. No worries.
Okay. Thank you, ma'am.
I'm trying
Okay.
to write my email ID. If you want, you can contact.
Yes.
So once again I formally thank Dr. Shahul for his excellent presentation and sharing all the details of the project and everything. Thank you once again. Thank you participants for patient listening. We will meet in the next session at 2 p.m. Thank you everybody. Sir
Okay,
Anand sir,
thank
you
you.
can note down the mail ID and contact number. It's on the screen.
Okay. Thank you, ma'am.
Thank you everybody. Thank you.
Thank you, Professor, for giving wonderful opportunity to share my work experience with the
It's,
academics.
it's a
It's
pleasure, sir.
pleasure.
Thank you.
Thank you.
Thank you, Professor. Thank you. Thank you all. Thank you all.